Hi everyone! Move on to C13. When C11 doesn't work, just make C13 from C11, giving expo 3 as in video 30. 9 times 1, 3 times 9, 1 times 9. Once again, when there is common factor 9, divide them by 9. Then 1 plus 1, 3 plus 2, and 3 minus 2. When the 1 has no 13, there is no factor 13. And the 5 has no 7, there is no factor 7. Being less than 250, it's a prime. Precisely 17 squared, according to the prime check principle, as in video 35. Let me call 7 hinge 13, 10 minus 3. 9 is hinge 11, 10 minus 1. Once again, when making C13, change this 1 into negative 9. 21 is 30 minus 9. Then giving expo 3 as in video 30. Common factor 9. 2 plus neg 1. 1 plus 1 and 1 minus 1. 0 means factor 13. Without changing C11, you can make C13, though it's slightly bigger, still showing the same result. Once again, when making C13, change this 7 into negative 3, 30 minus 3, to make it smaller. Common factor 3, then the alternate sum. 5 plus 3 hinge. No 7, no 13. Next example. When C11 and 13 don't work, C23 and 1 next, giving expo 2 to C13. Then alternate sum. Sum and difference. 1 has no 23. And 35 no 17. Then C21, giving expo 2 to C11. This time, only the sum, for 19. So it's a prime, according to the prime check principle. Memorize 800 approx threshold. No need for C31. Next example. 5-digit C11. The alternate sum. And the rest. Then sum and difference. If C11 works, you can make smaller numbers. Next example. Making C13 is not practical. These numbers are too big. Move on to the principle. I just leave a justification for C23. Using skeleton. Go to video 30 and 19. Okay, let's move on to the drill. Okay, thank you for watching. See you next time. Bye.